Hello friends, let's start. So today we'll see the big picture of Linux. So it is like just we are showing it's a really big. You need to understand it. See, the what we are showing here is like when we write a program in a Linux and we are using the kernel, and kernel is completely controlling the hardware as well as the user programs. So the kernel is a interface between the hardware and the user program. Why it is so, like we don't want to allow user to mesh with the hardware, and that hardware are not a simple hardware, they are pretty complex hardwares like USB and your displays and Ethernet and all this thing. Like if you see carefully, if you writing a code from the scratch, it will be pretty big source code you need to write, and that protocols used here, it's a huge pretty complex. So that's why we are using like see, all this code is already written, but now we don't want to allow user program to directly mesh with the uh, USB or Ethernet or any such kind of thing. That's why like the kernel is take over the charges, and it will handle each and everything in a process. And how it will interact, it's using system call. We'll see in a detail for a short while from now. So you can see here, like we are having a user space where user is mostly writing the applications, and those application are when they are in running, so it is called process. So like say in terminal, if you are writing a ls or mkdir, this is called the any program in execution, we can say the process. Although like it's not a 100% true definition, even like a process can be sleep or process can be blocked. In that time the block process is not running, but still it is a process. So like what I'm trying to say here is like a user program, you can just for simplicity you can consider at this point of time the process is like a user program which is in running condition. And like we are another thing, we are having the shell, like the terminal. So if you use the Linux before, then I'm sure you must use the terminal, and where terminal you are giving the commands like ls mkdir or maybe cp or mb or what's not. So you are giving the commands. So when we give command over the shell, it become the process. So process, we can either it will be like we are creating over the shell or terminal, or the process can be generating them there itself one after the other. So how this process are communicating and how these processes are working actually, so they are using the libraries and the system calls and the signals. So system call and the signals, this and library, they all are like piece of code, and like how they are communicating with each other to make the some significant task, significant application of the user program. In order to understand in more detail, because see, user space application is only it cannot directly talk to the hardware. In order to talk to the hardware, we need to go through the kernel space. So let's see what is in kernel space. Yes, in the kernel space, definitely we are having the kernel source code, and apart from that it's having a drivers. So this is called the Linux device driver, where like this is the famous term Linux device driver, and many people want to learn about like what is Linux device driver is. So you can say like if any hardware is there, that hardware kernel is maintaining. Yes, that we understand, but how kernel is maintaining? So for that we are having some piece of code. And that piece of code is running in some specific manner, so that Linux is able to understand and control the hardware. So this is called the a device driver. We will see in detail this thing in our upcoming lectures. So apart from that, this kernel having another responsibility to execute the user space application. And how it execute user space application? For that it is using the system calls and signals. The system calls and signals are directly talking to the kernel, and based on that it executing. Consider you want to display something on a display, or if you want to scan, if you are using the scanf. So for that purpose you need to use hardware. The hardware usage is only possible when you are going through the kernel. We will see all this in practically from our upcoming lectures. Apart from this, the kernel is having the network driver and the network related hardwares which it is using for the communications. So that is like one kind of big picture. You can have a look here, where like it's showing the programming model of the entire Linux kernel, as well as the kernel space and the user space. We will see in more detail, but now the prospects, it's little changing. We are thinking towards the hardware side now. So I will show you like how hardwares are playing role in all these things. So consider here we are having a user application, and that user application, if it need to do any sorts of activity, then it has to use the system calls. As we seen earlier, the system call are basically part of the kernel. So you can see like here also it mentioned as a part of the kernel, and this kernel is normally saved into a hard drive. So your kernel, it's a complete source code which is saved into hard drive. Hard drive is like a permanent memory where like your all sorts of data it's saved. But the issue with hard drive is like program cannot be executed from the hard drive. It must need to be in the RAM. So you can see here we are having now RAM. See, the hard drive size normally nowadays it's like 500 GB, 1 TB or maybe 2 TB also available currently in the systems. Apart from that, RAM, like normally PCs are having a 4 GB, 8 GB, 16 GB, even more than that. So this memory, like 4 GB, 8 GB memory, it's not a easy task to manage all those things, because it's a huge number of memory that need to have some sorts of management, and that management is done by the memory management unit. This MMU is like one sorts of, you can say like it's hardware also available, in software also it's available, or it's a combination both. So the memory is one kind of like completely managing the memories. This MMU is basically part of the kernel. So kernel is using MMU, and means you can say both are same thing. Means the MMU is a part of the kernel and which help to manage the entire memories. Apart from that, some big thing is the hardwares. So we are having a multiple type of hardware, say display monitor, networks, then DVD, then USB, then whatnot. We are having all sorts of hardware like touchpad, thumbpad, then the keypad, then mouse, and the other thing. So, and like we are having some other PCI devices as well. So all these are hardware devices which need to interact with each other, and of course this all will be controlled by kernel, no doubt in that. But now the main important component comes here, and that important component is CPU. You can see like none of this thing will work, none of like hardware, kernel, system call, nothing will work until CPU come into picture. So like just before some time I said like kernel is most important. Now I am saying CPU is most important. So why we have to see in this prospect, I'll tell you. See, the thing is here, the CPU will execute whatever we say to him, whatever program we write, CPU will just do it. But the problem is the RAM is very big, the hard disk is big, the USB and all these protocols are very complex. So how to manage them? So the managing part goes to the kernel. So kernel is managing all these things, and then on top of that it is giving the Then even the CPU, if you see the nowadays CPU are like quad core, octa core, and then they are working like maybe 2.5 gigahertz, 3 gigahertz, like that kind of speed in 1 second, 3 gigacycle. Just imagine. So it's like pretty fast. So all those management will be done by the software. The software is know like how to manage CPU, how to manage RAM, hard disks, everything. The all the program is written in the kernel. That kernel code is running in the RAM. And who is running all these things? The CPU is running. But who is running the CPU? So kernel is running. So you can see like it's a pretty complex thing, and mixed and match thing is here, which is used in our computer, and even like we are not able to realize the complexity hidden behind it. And you can see here like it's shown the one kind of connection where like CPU is talking to the hardware and it's communicating. If you see carefully, like CPU is communicating with the hardware. Of course CPU has to communicate, but what it has to talk, that will be decided by the kernel and the piece of codes which is associated with it. So this is another big picture of the Linux PC. Hope you are understanding. Here we had used the hardware and other detail. So that's all in this lecture. But here what we all concluded is, here we concluded what is the device driver. Device driver is a piece of code that is running in the, that is basically part of the kernel, and which is capable to handle the hardware. So either those hardware is already known hardware we are having, or we are having a some new hardware which is like user is newly created. Consider like say if you created any device, maybe USB device, which is like say reading a book, or maybe some other tab kind of thing, which is like you are interfacing over the USB. Or maybe you made some devices which is using the Wi-Fi or Ethernet port, and through that that device is remotely operating using your PC. So now when you made this kind of devices, those devices, the your Linux machine should understand those devices. In order to understand your Linux machine to those devices, you need to write the driver, so that device, your Ubuntu or any other Linux PC will able to understand. When you write a piece of code, that will become the part of the kernel, and the CPU will be executing, and that time you can add your new device here. This is a short introduction, so hope you it making some sense to you. And this is the series of like complete Linux device driver, and we will be going into deeper. So see you next. Okay, so let's start learning. It's a good thing. It will great boost for your career. Okay, have a nice day. Thank you.